All right, so we have a question here. We have our class intervals and our frequencies. The first part of the question says, convert the class intervals into class boundaries. So the reason why we're converting the class intervals into class boundaries is to accommodate for decimal numbers. Right, so this is how we're going to do it. Basically, as we're making these class boundaries, we're trying to connect each of the classes. Okay, because as you can see, this class is from 30 to 39. So for numbers like 39.1, 39.2, they cannot be accommodated. All right. So we need to close that boundary. Even if you look here, 49 and 50, numbers like 49.1, 49.2, they cannot be included. All right. So we need to convert these intervals into boundaries. So if we look at our first class, our upper limit is 39. Our second class, our lower limit is 40. Okay, so we're going to say 40 minus 39, that gives us 1. So we divide this by 2 to get the middle point, that is 0.5. So this 0.5, we're going to add it with all the upper limits. Okay, every upper limit we're going to add plus 0.5. Then all the lower limits we're going to subtract minus 0.5. Okay, so let's do that. So we start 30 minus 0.5, we get 29.5. 40 minus 0.5, we get 39.5. We're subtracting the 0.5 from all the lower limits. 50 minus 0.5 is 49.5. 60 minus 0.5, 59.5. And as I said, we're going to add 0.5 to all the upper limits. So 39 plus 0.5, 39.5. So as you can see, we've closed the gap with the classes. Right? 40 plus 0.5, 49.5. 59 plus 0.5, 59.5. 69 plus 0.5, 69.5. So now, as we can see with our class boundaries, we can accommodate decimal numbers. Okay, and as you can see, the gaps are closed between the classes. Earlier on, we had some gaps, but we've closed those gaps. All right, so these are our class boundaries. So that is part one of the question. Part two, we need to get the mean. All right. So starting from here on, we're going to be using our class boundaries. Right. We won't be using the class intervals. So the next thing, as I said, we need to calculate the mean. Right. So the mean, first thing you need to do we need to get our midpoints first. I don't know what's happened here. Yes, we need to get our midpoints. So basically, we're trying to find the middle number in our class boundaries. We want to get the middle number. So we start with our first class, right? We have 29.5, lower class boundary, LCB. There's a lower class boundary, upper class boundary, UBC. Okay, let me just make some space here. Okay, our upper class boundary 39.5. Okay, then we're always going to be divided by 2. Okay, so for our midpoint for the first class here, we're going to say lower class boundary plus upper class boundary divided by 2. We get 34.5. That's our midpoint. We go to the next class, we have 39.5, 49.5. So to get our midpoint, we're going to say lower class boundary plus upper class boundary with the parentheses divided by 2. 44.5. Go to our next class. Lower boundary is 49.5. Upper boundary 59.5. So to get our midpoint, lower class boundary plus upper class boundary divided by 2, 54.5. Okay. So we can see a trend here. 34.5, 44.5, 54.5. It's like we're adding 10. Okay, so 10 plus 54.5, we get 64.5. Those are our midpoints, right? So when you're calculating the mean, first thing, get the midpoints. Okay. Then now you multiply the frequency by the midpoint. Right, so multiply frequency by midpoint. Frequency by midpoint. Yes, those are our values. So in order to get our mean, we need first our total frequency and our total frequency by the midpoint here. Yes. So once we have these values, we can now calculate our mean. So let me transfer this back. Okay, so let me get the formula for the mean. So this is the formula for the mean. All right. Summation of fx, which is this one here. Summation of fx divided by, so this is the total of the frequency multiplied by the midpoint divided by the summation of the frequency, right? So here, 2049 divided by 42. So 2049 divided by 42, get 48.78. Right, so since our class boundary is at one decimal place, so we'll say 48.8. This is our mean. Okay, now we go to the next part of our question. They want us to calculate the median. Right, so let me get the formula for the median. Okay, so we need to get our table here. Okay, so we can see our formula for our median here. So the first thing, whenever you're calculating the median, find the position of the median class. This is the first thing you do. Find the position of the median class. Okay, so as you can see, get the position of the median class, it's n divided by 2. N is this total frequency. Okay, so we need to divide it by 2. Okay, so step 1, get position of median class. Well, I'll actually say step 1 is to make your cumulative frequency column. Okay, so our cumulative frequency, we're just adding our frequencies. Okay, so our first frequency is 7. Then our next frequency, we're just saying 7 plus 18. 7 plus 8. Let me just also get bundle. No, it's okay. 7 plus 18, that is 25. Okay. Now this method I'm doing is just for everyone to understand. Okay, there's a shorter method you can do, but I just want everyone to get the concept. The next one is 7 plus 18 plus 9, which is basically was just doing the same thing as saying this 25 plus 9, that gives us 34. Okay, then the next cumulative frequency, 7 plus 9 plus 18 plus 8. Basically, we're just saying this 34 we add it with 8, we get 42. Okay. But in the exam, you don't need to show all of this. You just put in your numbers there. So this cumulative frequency column will help us find the position of the median class. Right? So it says step 2, get position of median class. So in this case, it's n divided by 2. N is 42 divided by 2. That gives us 21. It's on the 21st position. Okay. So once we find the position, we refer to our cumulative frequency column. So we ask ourselves, where can we find our 21st position? So think of it like this. From the 0 position to the 7th position, this is for our first class. Our next class is from the 8th position to the 25th position. Then our next class is like from the 26th position to the 34th position. The next class is like from the 35th position to the 42nd position. That's how you can think of it. And then you ask yourself, where can I find the 21st position? You can find the 21st position here. Okay, that's where you can find our 21st position. Okay, so basically the class is from 39.5 to 49.5. This is our median class. So let me shade it. This is our median class. Okay, so once you found the median class, so let me do it like this. Oops. Okay, I don't know what has happened here. But once you find the median class, next thing that you need to do, so, okay, let me just erase this. I just want to clear up here. Okay, so our median class was found in the 21st position in this class. Okay, so once we find that, we now need to get our lower limit, our lower class boundary, I mean, for our median class. So lower limit, lower class boundary, LM. Our lower class boundary is 39.5. We're going to say equals 39.5. Next, we need to know what is the class width. So class width, WM, is the upper class boundary, UCB, minus the lower class boundary. So for our median class, the upper class boundary is 49.5. minus the lower class boundary 39.5. So our class width is 10. Okay. Next, FM, which is the frequency of the median class. As you can see, FM. Or we can find the cumulative frequency up to the class interval just before the median class interval. Okay, that's Cm minus 1. Okay, so C F subscript M minus 1. So just think of this as the cumulative frequency before the median class. Okay, and in this case here, the cumulative frequency before the median class is 7. All right, and then FM is the frequency of the median class, which is 18. So now once we've got all those values, we can calculate our median. So the median is, we can say, with this formula here, lower limit 39.5 plus our class width 10, then brackets, n divided by 2, the position of our median class 21, minus the cumulative frequency before the median class 7, divided by the frequency of the median class 18. So we're going to say 21 minus 7, that is 14. 14 times 10, 140. 140 divided by 18, we get 7.77. So we have 39.5 plus 7.7. We'll put it as 7.8. Because we're doing it to one decimal place. So 7.8 plus 39.5, we get 47.3. That is our median, the middle value. Next, we need to calculate the mode. So goodness with the mode, this is the formula here for the mode. Okay, so we refer to our table here. Right, so for the mode, the first thing you need to do is get the model class. Find the model class. Alright, so step one, model class. It's basically the class with the highest frequency. So the class with the highest frequency is this class 39.5 to 49.5. You can see the class has got 18. The frequency is 18, so that's the highest frequency. So our model class is 39.5 to 49.5. Right. So model class 39.5 to 49.5. It has the highest frequency. Okay. Step two. Found the model class. Now you start finding. So I won't really call this step two because we just now need to find the values we need to put in our formula. LM, which is the lower limit of the model class, as we can see. I mean the lower class boundary, 39.5. Class width WM, as always, upper class boundary minus lower class boundary, which equals 10. It's the same class width we got earlier on. 49.5 minus 39.5, that gives you 10. That's how you get your class width. Just upper class boundary minus lower class boundary. Right. So D1 is the difference between the frequency of the model class minus the frequency before the model class. All right. So FM, which is the frequency of the model class, is 18. FM minus 1, the frequency before the model class, okay, so D1 equals 18 minus 7. That gives us 11. Then D2, the difference between the frequency of the model class and that of the class interval just before the model class interval. So the frequency of the model class interval, 18. So our FM plus 1 is this one here. 9. So D2 is going to be 18, which is FM, minus FM plus 1, which is 9. 18 minus 9, that is 9. So we can get our mode, the lower limit, 39.5. I mean the lower class boundary, 39.5. plus d1, which is 11, over d1 plus d2, that is 11, plus 9, multiplied by 10. So 11 plus 9, that is 20. So I'm going to say 11 divided by 20, 0.55. So 39.5 plus 0.55 multiplied by 10. So we have 39.5 plus 0.55 times 10 is 5.5. So 39.5 plus 5.5, we get 45. That's our mode, the number which appears the most, 45. All right, now we get the standard deviation. So with our standard deviation, this is what we need to do. Okay, you need to square the midpoint. Yeah. So each midpoint we're going to square it. 34.5, we square it. 44.5, square that. 55.5, square that. And 64.5, we square that. After we square the midpoints, that's when we multiply them by the frequencies. Frequency multiplied by midpoint squared. So each frequency, we're multiplying it with the midpoint squared. Frequency by this midpoint squared. Frequency by midpoint squared. All right. So that's each of the midpoints. We multiply them by the frequency squared. Then we add them up. All right. This is our total. Okay. So let me just take this back to Word. All right. Well, the standard deviation. Okay, so let me get the formula for the standard deviation. All right, so we just need to get our values from the table. So sigma, oops, f x squared is this number here. Okay, so this part of this our formula, we get it here. Oops, so we get it from, just like make it tidy. All right, then here sigma f of x, this is our value here, this 2049. We need to square it. Then n is the total frequency. Okay, so this formula inside the root, that's the variance. Then the standard deviation is just the square root of the variance. Okay, the standard deviation just gives us the overall spread of the data from the mean. Okay, the overall spread of the data from the mean. Okay, so we get our formula here, square root. So summation of f times x squared is this number here, 103,990.5 minus summation of f times x squared, so we get 2049 divided by n is the total frequency, 42 divided by 42 minus 1. Okay, so start our tabulations. 2049 squared, we get 4,198,401. So I'm starting with this part here. 2049 squared, 4,198,401. We divide that by 42. We get 99,961. Is a point 0.9. All of this divided by 41. Okay, so 103,990.5 minus 99,961.9. We get 4,028.6. 1028.6 divided by 41. And we get 98.2. Okay, so the square root of 98.2, 9.9. So this is a small standard deviation. So the data values on average, they're not far apart from the mean. They're close to the mean on average. Okay. Then next we go to the quartiles. All right, so here we have our quartiles. So the quartiles divide the data into four equal parts, right? So the way we're calculating our mean is the same format we're going to use to calculate our upper and lower quartiles, right? So let's start with our upper quartile. So let me just get this table here. We're going to need the cumulative frequency again. It's going to help us show us our quartile classes. Okay, so for the upper quartile, all right, we need to find the position of the quartile class. First step, position of quartile class. The way we get that position, it is 3n divided by 4. Okay. So notice with the mean, the lower quartile, upper quartile, and median, the positions are found in the formulae. So for the upper quartile, it's this formula we're using. It's this that we're using to find the position. So we're going to say 3 times n is 42 divided by 4. So say 3 times 42, we get 126 divided by 4. 31.5. Alright. Or we can say, we can round it off to be in the 32nd position. Okay. So we come to our cumulative frequency column and ask ourselves, where can we find the 32nd position or the 31.5 position? Okay. You can use either two. Okay. So as I said, if we look at our cumulative frequency, right, from the 0 position to the 7th position is in our first class. Then the next one's from the 8th to the 25th position. Then next up from the 26th position to the 34th. Then from 35 to 42. Okay, that's why I used I rounded off this number so that we can easily find it in these. So the 32nd position, we can find it here in this class. Okay, which is 49.5 to 59.5. That's the position of our upper quartile class. And then everything is just the same like with the median. Okay, we find out The lower class boundary for upper quartile class, lower class boundary is 49.5. We'll say LQ, so we know where the figures are coming from. LQ lower class boundary, see 49.5. Okay, so that will put here 49.5. Oops, made a mistake here in this drawing here. Yes, our lower quarter. Okay, class width, as I said, upper class boundary minus lower class boundary. 59.5 minus 49.5, that is 10. Open brackets. 3n divided by 4, we got 31.5 here. Oh, since we rounded it off, so let me use just 32 to say 32. Minus the cumulative frequency before the upper quartile class, which is here, 25. Frequency of the quartile class, upper quartile class, 9. So I'm going to say 49.5 plus 10, open brackets, 32 minus 25, that is 7. So 10 times 7, that is 70. 70 divided by 9, that is 7.7, which can round out to 7.8. 7.8 plus 49.5, get 57.3. That's our upper quartile class. Okay. So the same format with even the lower quartile. Okay. If we have to get the lower quartile, okay, I can still use the same table here. Okay, the lower quartile, first we need to find the position for lower quartile. Right, the position is n divided by 4. So we can see here in the formula, n divided by 4. Okay, so we're going to say n divided by 4, that is 42. I mean, 42 divided by 4. 42 divided by 4. 10.5. So the position of the lower quartile class, you can say it's the 11th position. So we come back to our cumulative frequency column. So let me get rid of this. Oops, remove it. Yes, we come to our cumulative frequency column and ask ourselves, where can we find the seventh position? And it's here in the first group. The 11th position. The 11th position, we find it in the next group here, from 39.5 to 49.5. This is where we find the 11th position. So just put it like this. So the 11th position, we find it here. So meaning our class is this one here. So the lower limit, 39.5. Plus class width, 49.5 minus 39.5, that is 10. Open brackets. N divided by 4, that is 11. Cumulative frequency before our quartile class is 7. The frequency of our lower quartile class is 18. So 11 minus 7, that is 5. 5 times 10, that is 15. 50 divided by 18, that is 2.7. 2.7 plus 39.5, 42.3. Okay. And as we can see, 42.3 falls in this between 39.5 and 49.5. And even for our median, I forgot to mention, for our median, as we saw, our median was, what value did we calculate for our median? Oops, I raised it. But it should fall between the classes, okay? Even our upper quartile class, we saw it was 51.3. Our upper quartile class was this class here, and it fell in this range. So you can see our lower quartile, 42.3, falls in this class boundary, 39.5 to 49.5. Then what we can say, so our lower quartile, 42.3, that's, we call it Q1. Our upper quartile, Q3, 52.3. Right. So if you want to get your interquartile range, it's just Q3 minus Q1. 52.3 minus 42.3, that is 10. Then for the coefficient of variation, It's just our standard deviation, STD, standard deviation divided by the mean. Okay. Our standard deviation, I recall, was 9.9. Our mean, oh, yeah, so here was our median. Our median 45, as I was saying, it falls in the class here between 39.5 and 49.5. Thought I lost the median. Yes. So your median, your lower quartile, upper quartile, they must fall in the ranges of the classes you found. Okay, 45 is in this range between 39.5 and 49.5. Now back to what we're looking for. The mean. The mean is 48.8. We're trying to get the coefficient of variation. Basically, how consistent is our dust data? Okay. So standard deviation 9.9, mean 48.8. 9.9 divided by 48.8, 0.2. So it's not that our data is not that consistent. Higher coefficient of variation means your data is consistent. Okay, meaning a lot of values are close to each other.